I found this on Google. This one, like,
Yeah.
so someone is also facing the issue. So they are
Hmm.
saying like using this, install this code resolution design for .NET Core, this code generation design tool that need to
Yeah,
install.
that's what. Basically, we need to play around with certain packages, and that will need some time practically. So not
Yes.
only this package, sometimes the dependency packages also are not getting installed by default. Ideally, this should be done on its own whenever we are running the code generator. But Visual Studio is failing to do so. The troubleshooting will take some time. For sure, we can find the solution, but we need
Yeah.
time for that.
Yeah.
Okay.
Only this is maybe the person who is facing issue. He has to install this.
Yeah, meanwhile, you can try this definitely. Try installing this package with the same version 5.0.0.0. If it works out, well and good. Otherwise, anyhow, we will be looking at it. Okay.
Okay.
Actually, Saket, we are not
Yeah.
able to upload to Google Drive.
Yeah, so I'll work out with Ankita. Ankita, if you're there.
Hello. Yes, Sakit.
Yeah, we need a small support here. Like there was a hands-on assessment also. Uh,
Yes.
on Monday, and people need to submit their projects,
Mhm.
whatever they have worked with. And I asked them to upload it to some Google Drive or OneDrive, but I guess due
Mhm.
to the policies, it's not allowed.
Correct.
So can you provide us some solution for that so that they can share the code with me?
Um.
Actually, Quinnox OneDrive, we have access. We can upload it. We can.
OneDrive, you may be able to, but again, because of the cross organization policies, I may not get the access.
Yeah.
Yeah, means your email doesn't show access actually, means
Correct,
it is
correct,
not allowing. Yeah.
correct,
But
correct.
guys, you can access your personal Gmail through Quinnox login, I guess.
Yeah. Gmail is allowed, but Google Drive is not
Google
allowed.
Drive.
We
Okay.
We
can
can share the Git
access.
repository.
So Git repository, will it work, Sakit? If you
It
can
will, it
share
will.
one,
Yes,
then
yes,
I
it will.
guess it will help. Because in fact, for me, it is not allowed to access any other drive as well. Even I'm
Yeah,
struggling
yeah.
for a course to download. So
Okay.
it will be very helpful if again they are undergoing this Git training currently. So
Yeah.
that will be also a hands-on kind of a thing if they use the Git.
Sure, sure, sure.
Sure. Okay. Any other things,
Okay.
Akit?
That's it. That's it.
Okay.
Thank
Thanks.
you. Yeah. Okay. Then, guys, anyhow, we are going to start with Git. So, those who have not worked with Git will get to know how to work with it. Those who have worked in the past, they already know what to do to upload the assessment, I mean, the practical assessment on the Git. And that Git repository link you can share with me on the mail. Okay.
Saket, one question. On
Yeah.
this Git, we're also going to learn how to use Git in Visual Studio, right?
Yes.
Oh,
Yeah. So primarily we'll be starting with commands only because that is something which is heavily used. But then towards the end, we will be looking at how to use the Git integration in Visual Studio, which actually automates those commands, nothing else. Process remains the same, just that we don't need to remember and write the commands. Okay,
correct.
fine. So the agenda for today's session is on the screen. We'll be starting with the introduction to Git, which includes overview of Git, what it is, what it does, what are its benefits, how to set up the Git and configure the basic settings, then understanding the Git workflow, how it exactly works, what we need to do for it, and then exactly how to create a Git repository, and then very specific DevOps type features that Git also supports and offers. So there is a very important feature with respect to DevOps, that is branching. What branching is, what different branching strategies are there, and why it is important, where it is required, and what are the benefits. And then we'll be looking for the best practices for the branch management, and then we'll understand how to create and manage branches in the Git repository. Then we'll move on to focus more on the Git commands, what different Git commands, their functions, the commonly used Git commands like add, commit, push, pull, what they are, what they do, and how to actually work with them. Best practices for the same, and then using the Git commands on a Git repository. Okay, so let's start with the first section, introduction to Git. So what exactly Git is? Now, before that, I put a problem statement in front of you guys. Let's understand the requirement first of all, why something like Git was required. Okay, so suppose you are the only person working on certain project, a simple project you are making for inventory management for some grocery store. It's not a very big project, simple project. They have a requirement where they can just keep track of the inventory, and they can do the billing also, which ultimately updates the inventory. We are not even thinking of the accounting part of it. Most likely for such stores, they do their accounting with the softwares like Tally, right? So they just need the inventory management probably being done in a customized manner. So their specific requirements they are looking to get fulfilled. And that's where they have decided to create the product. Okay. And they came to you, you said that, okay, you will be providing them with the solution. Okay. So do you think there will be a requirement for sharing your project, sharing your source code with someone else during this process?
Yes.
I don't think so. Reason is you are the only person who is working on the project. We started with that, right? You will be responsible for requirement gathering. You will be responsible for analyzing the requirement. You will be responsible for architecting the product. And then you will be responsible for developing the entire source code, testing the source code, and then deploying the source code as well. I mean, the compiled project at the end. Again, deployment will depend on what kind of project it is, whether it's a desktop system, whether it's a web-based system. Most likely for a grocery store, simple grocery store, not the superstore I'm talking about, you don't require the multi-user environment also. Single terminal will be used, so it can be a standalone desktop application with no client server in place. The only server which you might be looking to use is the database server. In this case, the requirement is pretty simple. Your code stays on your machine during the entire process. And when you create the deployment package, it is the only deployment package that you will be taking to your customer system, where you will be installing, configuring, and making it active to be used by your customer. Am I right? So things look pretty simple and straightforward, isn't it? Now there is another requirement. You are building the same project for a store like DMart, Superstore. There are multiple billing terminals, correct? Multi-user system you need to build. It is going to be a complex project. So is it possible that only a single person can build the entire application?
No.
You need a team, maybe team of 2 people, 3 people, 4 people, 5 people, depending on the complexity, depending on the amount of work, depending on the number of modules you are looking to add. the size of the team is going to be decided. Am I right?
Yes.
And all team members will be working on completing the same project at the end. Whatever work they are doing independently, that is going to contribute to the same project at the end, because your project will be built as a whole, as a single unit, and then the deployment will be created on that, on top of that, right?
Yep.
So what is the challenge that you face? How do I share my code between my team members, right? So my first problem identified is sharing of code between team members, right?
Yes.
Yes.
Any other problem that you see here? Even if you're working in a simple project and you are the only person working on that project, there is one problem you will face there as well. And this same problem is going to be faced here in a multi-member team as well. That is, like, if I modify some code and I realize that there is something wrong that I did, how do I undo my changes? Undo feature can be used up to certain extent, but if you have saved and close your file and then reopen and then you want to use the undo feature, it won't work. Correct?
Yes.
So practically, how you handle this? Most likely you end up creating multiple copies of your project.
Yes.
Now with that, there is always a chance that there can be a wrong copy that I modify, or by mistake, I start modifying the project without copying it further. At times it may happen, right?
Yes.
This will bring in lots of inconsistencies. This will bring in the problem of having some irreversible changes into my project. Yes or no?
Yes.
Now, this becomes a different issue altogether. This is where I need something called as version control. I give you a simple example. You are working on a Word document or Excel workbook. You make some changes and you realize that maybe a day or two later, you realize that the changes which I made are not correct, or they are just partially correct. I need to revert back to the original version and then I need to make changes again. Or I just want to revert back to the older version. This is where I look for something called as version control. Do we have this support by default in any system?
We have to use the Git for this Git or source control, any source control.
Correct, correct. So version control is something which is not available by default. And most likely in such cases, you need to you end up creating multiple copies of the project manually, which is more error prone. Correct?
Yes.
We need some sort of automation for this. We need some sort of tooling for this, which can take care of this version control for us. So the other need comes in as I need some version control tools, right?
Yes.
Plus, when I'm working within the teams, my code might be available on multiple machines, basically on each machine of each of my team member, right?
Yes.
So this is where I have another requirement, that is distributed code. I need to make sure that after this distribution, the code remains in synchronization. Right? Just distribution is not something which I'm looking for. Probably that can be fulfilled by this, but synchronization of the distributed code, who will take care of it? Don't you think this is a challenge?
Yes.
Right? Now, while working with all this system, all these kind of features, how do I say that as a team member, I am working on this file, this source code file, I'm modifying it. These are my changes, and I want these changes to be confirmed into my system. This is where I need some sort of features like where we use the terms as check-in, check-out, and sometimes we use the term something called as commit as well. Yes or no?
Yes.
Right? So commit can be taken as a synonym for check-in also. Correct?
Yep.
And then the same project probably being developed for two different clients. Some base code is same, but then there are some changes as well at the end. That is where we require some sort of branching, right? At
Yes.
times we might think that, okay, the requirement have become quite similar and I need to merge the features from the two branches to one. So this branching might also have a requirement of merging two or more branches into one. Correct? This branching may also help in case if we want to don't if we don't want to modify the original source code which is already working and we want to bring in some changes. The changes might be corresponding to some new requirements being added with change request, or it could be because of some bug that needs to be fixed. We want to try it out first, whether it works well or not. I mean, the new solution works well or not. If not, we just don't want to use it at all. We want to discard it or we want to keep it separate from the main branch. And if all goes well, we decide that, okay, this branch now needs to be merged with the main branch and the feature should be available with the main branch itself. So that also comes with this feature, which we probably will require, especially working in a multi-user environment and multiple copies of the project or multiple versions of the project, right?
Yes.
Okay. Now, this is where some tooling comes in. And this now is something which is put under the head called as DevOps, developer operations, right?
Yep.
Under Microsoft, or I would say Microsoft as a company identified this need, came up with some of their own solutions across the years, correct? Different toolings they introduced, their own version control system, which only solved some of these issues, not all. Maybe code synchronization and what version control teams. First three basically they allowed. But then proper DevOps features were not available there. They came up with something called as Visual Studio Team System, which probably took care of the complete DevOps activities, right from writing the code to build to deployment, everything, complete CI/CD they allowed, right? Which also included the automated testing, or triggering of the automated testing and so on, right?
Right.
And just like Microsoft, there are other vendors who came with their own solutions. Not only the vendors, at the same time, there were lots of open source communities also who kept on developing and bringing in different solutions for this problem. Now, the products or the features that we get from the open source community, we have an advantage with them in most of the cases. What is it? They're open to change. Like the behavior, I can actually modify to suit my requirements. It's not fixed, which will be the case with a vendor specific implementation, right? I can just make it behave the way how my requirement is there. Completely can be molded the way how I want, right? And I can make a customized solution out of it, which suits my company requirements, right? Plus, because of multiple engineers working across the world in that community, new features keep on getting added at a very fast pace, and which keeps the entire implementation near to the actual real world requirements. Correct?
Yes.
Ideas from different engineers working with different organizations or working as freelancers keep on coming in. The problems that they face in their day-to-day work, probably they try to get it solved with these open source community work. And that's where we get best of the possible solutions. And this is how the Git also originated. So Git is basically something which provides me this solution. The solution for these requirements.
And this is open source.
Git itself is not something which provides. Guys, am I audible?
Yes.
Yeah,
Yes.
I guess there was something wrong with the network in between for a few seconds. Just give me a second. Right. So what I was saying is like Git performs certain actions within the DevOps planning, but Git itself is not something which can be termed as DevOps tool. Git is the part of the DevOps tools kit or tool set. Make sense? It does provide some of the features which are essential for DevOps. Particularly, these are the requirements that it targets and provides the solution for. Got my point?
Yes.
Okay. So let's talk now more about the Git. So what is Git? It is basically a distributed version control system. Distributed version control system whose primary usage is for I'm sorry, tracking changes in the source code during the software development process. Now, this is not a new thing. Even Microsoft Word has got the track changes feature, right? Probably taking a clue from there only. The changes in the source code also were possible to be tracked. right? It was first of all introduced in 2005. And since then, it has become an essential tool for developers, especially who are probably the startups or who are running the startups or who are working as a freelancer, because it doesn't require any kind of license to be purchased. But then eventually it became so mature and so big that even the big organizations also started adopting them, right? So primarily this allows the teams to collaborate on the projects, manage the different code base versions, apart from tracking the changes over the time, and that too very efficiently. Understood?
Yes.
Let's talk about some of the Git key concepts. Okay. So first one is simple, which aligns with our first requirement. It does provide a version control system, VCS. Git itself is a version control system. That means it helps the developers to manage the changes to their code base over the time. It just keeps track of the changes, and not only the changes, but apart from the changes themselves, it keeps track of who has made those changes, when the changes were made, date and time, apart from what was actually changed. Is it important or not?
Yes.
Yes.
Otherwise, the changes made by one member probably maybe the unacceptable changes as well at times. Yes or no?
Yes.
So kind of a log is maintained, right? Who is doing what at what time, what date, right?
Yes.
Because it keeps track of the logged in user also, right? Next, it is completely distributed. Now, what does this mean? There are two ways the version control system can work. One is centralized version control system. One is distributed. Centralized means there will be a server on which your repository will be created that holds your code base. Every developer on their individual machine will just get the code base copied, not the complete repository. When I say repository, it's not only the code base, but all the tracking information also, including the history of changes made. Understood? Now, if I'm looking for a system which is independent of a server, which allows all the team members to maintain the exact copy of the entire repository, and which is automatically synchronized also across the different copies. I need a distributed system. So each developer's machine can have a repository which is exact replica of the original repository. There might be a server involved in this case also, but it will be just a common communication point. And even if that server goes down for whatever reasons, I don't lose my work at all. I can just recover my repository from any of my team members, right? And temporarily, any of the team members' machine can be treated as the repository server also with some configuration, correct? So what is safe? Centralized version control system or distributed? What is safe in terms of high availability of your code?
Distributed.
Distributed.
Of course, distributed. And that is probably the need of the hour as on today, because your projects are quite huge. Not like 90s where we had very targeted uh, requirements being fulfilled by the softwares and which made the size of the software to be very small. These days, softwares are very huge. Yes or no?
Yes.
Next is it comes up with repository implementation. So practically, what is repository? If I want a definition, it is just something that can be compared with a simple directory or a folder that contains all the source code files, the history of the changes for the specific file, history of changes made for the complete project also. Okay. Now, here also there are two types of repositories possible. One is local repository, which will be on the developer's machine, and one will be something called as remote repository, which might be on a server like GitHub, GitLab, Bitbucket, etc. These are all Git repositories only. GitHub, GitLab, or Bitbucket are all Git repositories, remote repositories. So if you don't have the enough hard disk space available on local machine and you want just the centralized repository to be used, you still have the choice by opting for the GitHub or GitLab. Or if you are looking to have the repository shared across the machines which don't have the direct connectivity between them, then also you will require GitHub, GitLab like or any other remote repository, which is what we are going to need for our practical assessment as well, because your machines and my machine are on two different networks, two different domains, right? So we cannot have a local repository which I can get the access to. Yes or no?
Yes.
Next is commit. So with databases, it's easy to understand what is commit. Commit means whatever changes in the transaction have been made should be made permanent. That's what the meaning of commit is, correct? So practically with Git, what it means. Commit actually is a snapshot of your code at a given instance of point in time. Each commit will generate a unique identifier with the help of hashing algorithm and contains the changes you have made since the last commit. That's how it tracks. Commit 1 was probably initial commit. Whatever the initial code developed was committed. Now from then, whatever new things you have done or changes you have made to your existing code will be the part of the second commit. And so on. Understand? Understand?
Yes.
Yes.
Yes. Yes.
Next is branch. Little bit we already discussed about it. So if I ask you the definition for branch, what is it?
Create a separate.
Yeah, go ahead.
It's a replica of the master branch. Means we have one master branch and we can create the another replica of the same branch.
Yes.
So we
And
can
what
see
is the
that.
need for that?
To handle the different users means in current project we have different means there are many team members, so they can work individually on their feature branch or individual branch, and they can push their changes in that particular branch only, and later they can
Don't you
merge
think more
it.
effective will be creating a new branch for all the users, which is common, and work on the research related stuff on that branch itself? All people in the team will be working on that same branch. Purpose is to keep my already working solution safe.
Yes.
Don't touch the already working solution at all. Keep it isolated. Get a copy created, work on that. Whatever research you want to do, what are new features you want to introduce or you plan, do it on a separate branch. And if all goes well, merge it with the main branch. Right?
Yes.
Yes, yes.
So it seems like
That's
that
the overall
prod
idea.
and deploy development. No?
Correct. Correct. So prod is the main branch, and whatever changes you are making, that comes under development branch. And then maybe there are two teams who are working on two different feature sets, one for client one for client two, where the main code base is the same. There also the branching comes in. Hence the term branch has been used, right?
Yes.
Like for .NET also, Microsoft created two branches. Apart from the main branch, one branch was created to take care of .NET framework, Windows only. And another branch was created for .NET Core, which was cross-platform. Later on, they reached a point where they decided that, okay, now the feature-wise, the both the branches are providing the similar behavior. So why not merge them? They merged the two different branches into one, and that became the main branch again. So again, in future, if they plan something else, probably another branch may come out. Yes, I'm not saying that different branches are always going to be merged at some later time. They may or may not be. Depends on the purpose, depends on the need, right?
Yes.
Next is merge. So if I've created multiple branches, and I think these changes should become available into the other branch as well. Let's say two different research works were being done, and we find that, okay, the work from both the research works should be combined into one branch and tested in an integrated manner. And then if it goes well, we plan to merge it with the main branch. In all cases, the feature called as merge or the concept of merging is going to be needed. So very, very important, so that we can incorporate the new features or the bug fixes into the main branch. Yes,
Yes.
there is another key concept which is related to Git, something what we call as PR or pull request. Pull request or PR. What is it?
When we create some kind of code and we want to sure before it's merged, someone has review it. So we create pull request, and after it accepted or approve, it will merge to the master branch or a specific branch.
Correct. So pull request basically is a request to merge changes from one branch into another by providing a way for the team members to review and discuss the code changes before they are merged. So in a conditional manner, if we are looking to merge it manually, the decision making is going to be done. That's where the concept of pull request comes in. Yes.
Yes.
Okay. Now let's talk about the basic Git workflow. Workflow means steps, right? Steps or the chronology in which we carry out certain actions. Yes. So what you have to do to work with Git, the first step is, first of all, you have to initialize a repository. Right?
Yes.
Second step, when the repository is initialized, it may not contain anything into it. So probably you have to add and commit some initial content. I will still call it as changes. This is something we can treat as first change, because ultimately the state of the repository is being changed from nothing to something. Yes or no?
Yes.
Right? So different commands are there for these actions. Probably there is a command called as add, which places the prospective changes in place, and then commit command might be used so that those changes can be actually be put into the repository, right? By capturing the snapshot. And then this will also include some commit message or the description of the commit, what exactly has been done within that particular commit or as a part of that commit. Got my point?
Yes.
Next step is to create and manage branches. Understand? What is branch? We already discussed. Create and manage branches. You can keep the branch separate as far as you want after undergoing thorough testing, unit testing, integration testing, performance testing, load testing, everything. Once you are satisfied, then only go for merge. Make sense?
Yes.
Next is now you can go with the integration with remote repositories. Local repository is something that you start with, but then to add more reliability, you might want your local repository to be synchronized with, connected to and synchronized with the remote repository as well. So that if something goes wrong with your system, there is a remote copy which is always available in the remote repository. Yes.
Yes.
This remote repository can be a custom repository server on your network, or it can be something in the public domain like GitHub, GitLab, Bitbucket, etc. Correct?
Yes.
And then we have something called as collab or collaboration. What is the idea behind collaboration? What is it? Making people work as a team on the same project parallelly. That is collaboration, right? I am doing my part of the task. You are doing your part of the task. Someone else is doing their part of their task, right? Ultimately, the goal is to have one project created at the end. So we are all, in a way, collaborating to build a certain project. Yes or no?
Yes. Yes.
Yeah. Okay. Now let's talk about some of the very, very popular Git services that are available. We already discussed some of them. GitHub is one of the leading Git service. Then we have GitLab. We also spoke about Bitbucket. And then Microsoft also adopted Git as the version control system in their own product line, represented by Azure DevOps. Where Azure DevOps add further features like CI/CD and all. GitHub is only repository. GitLab comes with some of the DevOps features like CI/CD pipelines. Bitbucket is again just repository, whereas Azure DevOps is a complete DevOps solution. Not only CI/CD pipelines, but it does provide many of the other features with respect to the complete DevOps solution. Lot of automation it brings in. For repository, behind scenes, it uses Git only. Understand?
Yes.
So with this, we can see that Git has become an essential tool for the modern software development by enabling efficient collaboration, code versioning, project management, etc. Right? And learning this Git feature is not only Git feature, but the associated workflows also is quite crucial for the developers as on today, so that they can work on the code, they can work on the projects collaboratively and maintain a well organized development process. Yes.
Yes.
So what are the benefits of Git? Based on our discussion, you can just list down some of the benefits. Just help me out.
Version
Maintain.
In
control.
recap, first is of course version control.
Maintain history of all the changes.
Yeah, so that is version control, right?
Yeah.
Next, collab or collaboration, right?
Yes.
Then multiple
Accidentally.
copies of the project with the help of
Branching.
branching. Then it allows us to review the code also efficiently. Before I say commit, I can get the code review done. If all good, then only the commit will be performed. Yes or no?
Yes.
This will ensure the code quality and it also ensures that the best practices of the software development are being followed before the code gets or the work gets merged with the branch. Correct?
Yes. For
How do
example,
we
a
get
machine
this
is
done? Yeah, go ahead.
one of the benefit is like, for example, I lost my machine or format, so I can get the
Yes,
copy. So
correct.
data recovery.
Correct. So that is again with the help of version control, right? If you
Yeah.
have a remote repository, you can recover. If not remote repository, your team member might have a repository already. So you can just uh, synchronize a new copy on your new setup, right?
Yes. Yes.
Something where we say create a clone.
Yes.
Now, how do we get this code review done? This is where we make use of something called as pull request. Correct?
Yes.
Yes.
Next, we have a completely distributed workflow. Because the Git nature itself is decentralized, which is important because at times you may be working at some location where there is no connectivity altogether. So with distributed or decentralized nature, the developers, the team members can work offline as well, right?
Yes.
And once they are back online, probably they can sync their changes from local repository to remote one, correct?
Yep.
So by default, I have the next feature or benefit of using remote repositories, where the four type of repositories are being used heavily: GitHub, GitLab, Bitbucket, and Azure DevOps. Correct?
Yes.
So this actually provide a centralized location for hosting and sharing the repositories across team members at different locations, different parts of the world. The collaboration further easier. Next, code security. So do we talk about the authentication authorization here when we talk about code security or
Yes.
encryption?
Yes.
No, no. This is not about authentication, authorization, or encryption.
No, actually, if we give access to a resource only, they are able to have access to the
Yeah,
repos.
but it is not Git which does that. It is the tool built on the top of the Git which probably provides us that. Like in .NET environment, it is taken care of by Azure DevOps. Okay. So accessibility is different. Security is different. Security here means that unwanted changes can be avoided. Even if they are done, probably we can just restore back to the original because of the version control, right? And then the tools built on the top of Git may provide the accessibility or access control in addition to the basic version control, so that your repository itself can then be secure. Right? So code security is one thing, and then we have repo security also, repository security, which is where the authentication authorization will come in. Understand?
So this code security, I am not understanding.
Yeah. Code security means unwanted changes can be undone or they can be rejected. Even if
Okay.
someone commits the changes, basically those changes are automatically going to trigger a different version. So if I feel that, okay, some unwanted change has been done, I can just revert back to the correct version, right?
Yes.
So this is actually achieved by version control only. And repo security or repository security is managed by access control, means authorization, which is ultimately based on authentication. Okay.
Yes. Okay. Thank you.
Next is flexibility. What kind of flexibility? So practically, it is not limited to the code or code files. You can use Git for tracking the changes for any type of file. It could be Word document, PDF, Excel workbook, or it can be any other file. So not only the development projects, for other projects also where lots of documentation being done, this Git can be useful there also. And those people can also get benefit of collaborative environment with version control and everything. Pretty crucial, right? For the businesses which depends a lot on documentation. Yes or no?
So there will also will create branch and we'll
Yeah.
modify the document.
Yes, yes.
Circuit code security and repo security are same or like yeah.
Two different aspects, but come under the same term called as security. It is just two different aspects. Repo security means the complete folder being secured. Who can access and up to what extent the person can access it. So that is authentication authorization. Code security means by no means my code should be lost or should be having any unwanted changes into it. So two different aspects. Understood?
Yes.
Next, as we discussed, is Git is completely open source. What is the benefit of it?
Free of cost.
We can customize as per
No,
our
open
requirement.
source and free of cost are two different things. There are
We can,
multiple open source projects which are licensed.
uh,
Open source means the source code is available, which
We
may
can
be available
customize.
free. Yeah, so which
we
may be
can
available for free, or we can purchase the license and then get the source code. Okay, so practically open source means the implementation is customizable or changeable.
Okay.
Correct?
Yes.
Okay, so they can customize the entire implementation as per their own need. Right?
Yes.
So I hope this is clear to all.
Yes.
Yes.
So time for break. We'll resume at 11:05 and we'll move on to a little bit of hands-on. Okay.
Yeah. Thank you.
Okay.
Okay.
Hey guys, I'm back. Shall we proceed?
Hi.
Okay. So first of all, we need to prepare our machine for Git. If any Visual Studio instance is up and running, close all such instances because we will be installing the Git, which is pluggable into Visual Studio as well. So any installation requires Visual Studio to be closed. Okay, then open the browser. It's not all, if it is not already set up, then only you have to do this. Search for Git for Windows. There should be a link from gitforwindows.org. So here it is. Git for Windows, gitforwindows.org is the website. Make sure you download from here. You should land up on the home page like this. And here you have the download button. Click on this. The download begins. Around 59 MB, so should not take much time if you have a decent internet connection. I'll wait for a minute so that it's downloaded for all. Okay, so once the download is completed, just click on this. Depending on which browser you are using, your download user experience might be different. So just accordingly see exactly where it is and then click on that download option so that the installer will automatically begin. There will be user account control prompt. Do you want to allow this app to make changes to your device? Click yes. And then the installation wizard like this starts. Meanwhile, we can close the browser. Click on install. If it is already installed, then also if you install the installer, it just updates your existing installation to the newest one. Usually the installer is pretty fast. I don't want to see any release notes or something for now, so I just uncheck this. I don't want to launch the git bash shell also. So just make sure both the checkboxes are unchecked. Click on finish. Your installation is done.
For me, it's asking next.
Okay, just share your screen.
Yeah.
This is the first step.
Yes,
Can you
back.
click on back? Yeah, so after agreement, click next. This is, okay, let's change this a bit. Click on browse. We'll install it in program files. Click on browse. Select C drive, program files, and click OK. Next.
Does not seem.
Okay, so you may not have the permission over here. No worries. Click on browse again.
I
Uh,
select.
yeah, I believe from here it won't allow. Just click cancel for now for this box and open Windows Explorer. It's already there in the background. Uh, Go to C drive, create a folder named as Git on C drive itself. Yeah. Enter. Close this window. Now go back to the installer and select this Git folder. Remove Git from the path. Yeah. Click next. Yes. Next. 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 Mostly the default options you are going ahead with. Yeah, so click next here as well. Next. 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 Next.
Yes.
Install.
Install.
So next time, whenever you run the installer again for updating the version, it won't go through all these steps because it will pick up from the original installation configuration only. Got it?
Yes.
As was the case with me because I already had Git installed. Some older version was there already. Done. Close this window. Finish. Close the browser as well.
Okay.
I'll share my screen now. Okay.
Yeah.
Now, how do we verify that installation is successfully done? So there are two ways. If you go to start menu, there you will find Git Bash app also, or you can go for Git CMD as well, or you can just open the CMD command prompt also. Let's open Git Bash. For better visibility, I'll just make some changes to the font. Size, where it is.
So what is the shortcut to
This
get
looks
that
great.
options?
Yeah, you
Okay.
can just click on this icon here on the top left corner, the control box, and there you have options. So I went to text and here I clicked on select to increase the font size. Just the font size I wanted to increase because this should be visible clearly to you as well. So the prompt looks like this. Here I just need to type the command git space dash dash version. And it shows the version installed. That means Git is installed, Git is available. Got it?
Yes.
I hope everyone is able to get the version displayed on the console.
Yeah.
Okay. Now we have successfully installed and verified the Git. Now is the time to configure our identity and some more basic settings so that the Git just identifies the user as well. So here we just say Git config. I want this to be done globally for this machine. So global user dot name, practically username. You can put your name, first name. Enter. The username has been set. Then again the same command I'll issue. Git config dash dash global. This time I want to set user dot email. You can set your official email ID as well. So I'll go for my official email ID. Enter. Done.
Yes.
Here then we need to configure our preferred text editor.
Saket, for
Yes.
me, it's showing command not found.
Can you share your screen?
Okay. Is it visible?
Yes, it is. Okay, so there is a spelling mistake. Instead of get, you put got.
Okay, okay. Yes, sorry.
Yeah,
Okay, got it.
just correct it. It will work.
Okay, yeah, thank you.
Okay, once done, just confirm so that we can proceed. So what I'm saying here is we need to configure our preferred text editor, which could be Notepad++, which could be Sublime Text, which could be Visual Studio Code, whatever you want. For now, we'll use Notepad, normal Notepad, Windows Notepad. So for that, again, it's git config statement only. Git config dash dash global core dot editor. I want to use notepad dot exe. If it is VS Code, you can put code.exe. So every text editor will have its exe name, right? That is what you can put here. Enter.
For VS Code, what you say means instead of
Code.
notepad.exe,
Code.exe.
Okay, okay, sure.
And this can be changed anytime. For now, you just keep notepad only so that we will be on the same page. Later on, you can run the same command again. Instead of notepad.exe, you can put code.exe. Okay.
Yeah, yes.
Next is I want to enable the line ending conversions, especially useful when collaborating with users on different operating systems. I am using Windows. My colleague is probably using Linux. Someone is using Mac. So I want that consistent line ending conversions. For that, I say git config global core dot auto crlf. Carry as return line feed to true. So space true. Okay.
Sorry, I missed some. Actually, what is the purpose of this command? See, auto CRLF.
Consistent line end convergence will be used. So on some machines it is CRLF. On some machines, some operating systems, it might be uh, just LF, or some machines might say that, okay, it's only carry as return, right? So it has to be consistent across different operating systems so that the
Okay.
script can run on any of the OS. I mean, the script can run on any of the uh, Git installation on any of the OS. Clear?
Yes, yes.
Next, what is the default name I want to use for my branch? So usually by default, it takes master. I want to set it as main. Again, I go for git config. -- global init dot default branch main. Remember, we are working on bash console panel, which means the code or the commands that we are writing here are case sensitive. Got my point? So just make sure you are using the correct case. Press enter here. If you are looking to use the SSH, that is the RDC equivalent on Linux, in that case, again, this could be required while connecting to the remote repositories from the bash console. So the remote repository could be GitHub, GitLab, Azure DevOps, or Bitbucket. In that case, you need to identify yourself on the remote repository as well. And that's where the SSH key pair will be required for securely authenticating yourself, for which we need to generate the key. And the command for the same is ssh dash keygen. Not only issue the commands over here, make a note of all these commands in a notepad file also with your comments, what each command is doing. Okay.
Yeah, the last one you explained.
Yeah. So -T RSA is the algorithm. -B, the port number goes here. Let's say, in fact, not port number, number of bytes to be used. So 4096 bytes I want to use for encryption for my keys. And then here I say capital C followed by the email ID that you have specified here in double quotes. Okay. Press enter. Asking for which file you want to save this key pair into. The path will be this C user socket.ssh ID RSA and the file name that you mentioned over here. So here, let's say for now, I give the name SSH key. Ideally, you should give some name which are not predictable so that the keys cannot be stolen. For simplicity of understanding, right now I'm giving this name SSH key. If you're not looking for any password phrase, basically, just press enter over here. And enter again. So your key is generated. You can see the snapshot of that key. The fingerprint for this key is here, which is actually the encrypted version of your credential. So using 4096 bytes encryption, this key pair has been generated. Is this clear?
Actually, what this will do, Saket?
See, when you are connecting to some remote server, maybe remote repository, do you need some kind of credentials to log into it or not?
Yes.
So the keys that you have generated over here will be your credential to identify yourself on that remote repository, because a local repository will be connected and synchronized with a remote repository, right?
Yes.
So which local repository to be connected to which remote repository, and for that what authentication needs to be used? There has to be something in common for credentials, right?
Yes.
That's what it is. So we have just generated the key, the credentials, kind of a digital certificate, you can say. It's not digital certificate though, it is just a key pair, but is used just like a digital certificate. Understand?
Yes.
Now you are ready to start working with your Git repositories. Clear? So for now, we'll keep this console closed. Let's understand few more concepts over here. Basically, here we are going to focus now on the Git workflow. Different kind of workflows which are available. Okay. So what is workflow? What we discussed?
It's sequence in which it follows.
Yeah, some work is carried out, right?
Yeah.
Sequence of the steps in which some work is carried out is what we call as workflow. And when it is Git workflow, it is more about the sequence followed for working with Git. Correct?
Yes.
Particularly while working with version control and other features, you will need to follow certain workflows. So different types of workflows are there. The first workflows which is available here is something what we call as centralized workflow. It is the simplest type of workflow and is usually used in small teams or for smaller projects. It basically is something that involves a single central repository where all developers commit their changes. The old school thing. We don't use the distributed repository feature in this. Okay. So the workflow which is applicable for this is where at first the developers clone the central repository. One of the team member will create the central repository, will put or push the initial setup. Then all the developers in the team will clone that repository from the central server. The central server can be a custom repository server or can be a public repository like GitHub, GitLab, Bitbucket, Azure DevOps, or something similar. Next is they create feature branches to work on specific tasks. Basically to add code. Okay. Next, once the task is complete, the developers push their branch to central repository. I'll just put repo. Next, a team lead or some equivalent person. I mean, any person with equivalent role as team lead or project manager or equivalent. It could be a module lead also. Someone with more development experience basically will be reviewing and merging the changes to the main branch. Okay. What are the benefits of centralized workflow we discussed? First one is simple and easy to understand. The second is more suitable for smaller team or a smaller project, or maybe both. There are some consequences of using centralized workflow also. Like it can lead to bottlenecks. If there is a single person, or what usually we call it in Git terminology is gatekeeper for the merging. There is a single person for that role who is responsible for review and merges. And then it has got limited support for parallel development. Limited means there is support, but quite limited. Understood?
Saket, same thing is applicable for the distributed workflow also.
No. Distributed workflow will have its own
But
different
similar thing.
behaviors. Like, yes, some of the similar things will be there, like cloning the repository and then managing their own repositories on local machine and just synchronizing the changes instead of pushing the whole stuff each and every time. And hence the consequence that we face with centralized workflow, like which gives limited support for parallel development, can be overcome. right? Plus, with multiple repository copies available, there can be multiple people assigned with the role of reviews and merges. I mean, we can have multiple gatekeepers for the same, right? So the time required will basically be improvised. And it can be suitable mainly for bigger, larger projects with big teams or multiple teams. This can be suitable, the centralized workflow can be suitable for a single team, right? Which automatically means that the project has to be a simpler one. Understand?
Yes.
Next is feature branch workflow. It is actually an extension of centralized workflow designed to support the parallel development of multiple features, new features, I mean, or it could be for bug fixes as well, where each feature, new feature, or the bug fix is done in its own branch. Right? So one of the issue that we discussed with centralized workflow was parallel development can be challenging. So feature branch workflow provides an advanced version of centralized workflow only. Main behavior is like what we discussed, but in addition, it has been optimized for parallel development. So multiple branches can be worked at the same time by multiple teams. So the complexity of project over here can be little higher as well. The steps here include developers create a new branch for each feature, each new feature to be precise, or a bug fix. Okay. Next, they work on their feature or bug fix in isolation. They work on their feature or bug fix in isolation. Means they just take care of their own work. Next is once the work is complete, they create a pull request here means pull request to merge their branch into main branch. And the last one is the team members review the PR or pull request. And once approved, the changes are merged. Understood? So what
Saket,
are the advantages? Yeah,
I have a
go
doubt.
ahead.
So, in main branch, so they will create a feature branch and bug fixing branch, and
Yes.
again this feature branch and bug fix branches will be merged into main branch.
Yeah, after approval means after code review is approved.
Okay. So,
If there is a rejection, they have to rework and then again raise PR.
okay. So, while merging, there may be conflicts also, right?
Yes, there is a possibility that there would be conflict, but that is a different topic altogether where we talk about conflict management, right?
Yes.
That's a
Okay.
separate thing altogether. Okay. So what are the benefits of this feature branch workflow?
Saket,
Yeah.
yeah, one more query. Actually,
Yeah.
when we create the new feature branch from the main branch, and after that, suppose some team member work on that particular branch for 5 days, and within that 5 days, get main branch get updated. So before merging that
Yes.
one, we should take a pull of that main branch, right?
Yes. So basically,
Latest
your
one.
tool will also give you the warning that okay, the main branch has been updated or something. So before you actually create the pull request, uh, take the changes into the main branch into account.
Okay.
Right?
Okay. While merging only means it is showing.
While
Yeah.
creating the PR. While creating the PR.
Creating the brand. Okay. Yeah.
Yeah. Okay. So benefits, what we discussed, mainly it is centralized workflow only, but with support for parallel development of features and bug fixes. Encourages the code isolation, which means easier testing of the changes, right? Now, what could be the consequences of this? Suppose there are 100 PRs that have been raised. So don't you think the PR management can become complex? The more the number of branches, the more complex the PR management would be, right? And as you asked, you also need to make sure that your feature branches are up to date with the main branch. If the tool has given you the input, that's good. If not, you have to manually test that as well. That my feature update has been taking into the consideration of any changes that are being made to the main branch. You cannot always depend 100% on a tool in such cases, right?
Yes.
So these are some of the challenges or consequences. Understood?
Yes.
Okay. Let's talk about another workflow type that we have here. Third one, Git flow workflow. Git flow workflow. What it is? It is more of a comprehensive branching model that defines specific branches for different type of works, which is more suitable for larger teams and more complex projects. I mean, whenever you create a branch, there has to be a clear or clarification about for what type of work or for what reason you are creating this branch. Is it for new features? Is it for bug fixing or what it is? Right? And it may target multiple features in one branch or multiple bug fixes in one branch as well. That's why we say this is more comprehensive branching model. Instead of one feature, one branch, one bug, one branch. So multiple things can be targeted in one single branch itself. Okay. There are some key branches associated with this Git flow workflow. The first of the key branch is main branch, of course. Second is main branch is also called as production ready branch or production branch. Next is development branch or develop branch. This is something which you guys most of the time would be using. Then we have something called as feature branch. Then we have something called as release branch. Purpose of each branch by its name itself is clear. And then we have something called as hotfix branch, which is for bugs. Right? So main branch represents the production ready code. Develop branch serves as a staging area for upcoming releases. Feature branch created for developing new features. Release branch prepares for a new release and targets or addresses the last minute issues. And the hotfix branch is used for critical bug fixes, as I said, in the production code. What are the benefits of this? Provides more structured and organized approach to development, supports the concurrent feature development, releases, and hotfixes, right? Just one consequence is applicable for this, which is that this Git flow workflow requires a very careful branch management and adherence to the model. If not done properly, it can just spoil the entire stuff. Understood? Understood?
Yes.
And then comes the last one that we have here. That is GitHub flow. Or GitHub workflow. It's more of a simplified workflow which is optimized for the teams that use GitHub for code hosting and focuses on continuous delivery, often used in agile and DevOps environments, with more of automation coming in. Okay. So what are the steps to be taken care of? Developers create a branch, for a new feature, or bug fix. Next, they work on branch, committing their changes frequently. Okay. Next is when ready, they open a PR, pull request for the review. Then team members review, and discuss the changes. In the PR. Once approved, the changes are merged. Into main branch. And now till fifth point or fifth step, this looks to be similar to our feature branch workflow, right?
Feature, yes.
The sixth step basically makes it different. After the merge, the changes are automatically deployed to a staging environment. For testing. Usually where the UAT happens, right? Staging environment is very much similar to production environment where the real users only try and test your software, correct, and give their feedback. And any last minute negative feedback can be then taken into account, and after making the changes, once again the activity is repeated. Once we get all clear from our, I mean the UAT test is all cleared, then we go for deploying to the production. So what are the benefits of this? It basically focuses or emphasizes more on continuous delivery and rapid iteration, and encourages the smaller and frequent releases instead of waiting for big changes. Any challenges that you see here with this? This GitHub workflow may not be very suitable for a long-lived feature branches or any complex release processes, because it talks about the quick releases, right? So I said this is the last one. That doesn't mean this is actually the last one. There are multiple other workflows possible, but these are the heavily used and followed workflows while working with Git. Is it clear?
Yes.
Let's move back to some hands-on. I'll just clear this whiteboard. Open your Git shell. Just search for Git bash and open it. Hopefully it remembers the font settings. Yes, it does. Whatever project you have and you want the Git repository integration for that project, you first of all need to get to that particular path. So let's say my project is at, let me open Windows Explorer. So we created a folder on desktop by the name Quinnox demos. The last one was web APIs. And in that, let's say I'm looking for demo web API with EF. This is the project which I want to be pushed into the repository. So my full path is this. Let me copy this to a simple Windows Notepad window. For our reference. C drive users, my username, OneDrive, desktop, Quinnox, demos, web APIs, and then this folder. I have to browse to this path. Okay, I close my Windows Explorer and go ahead with this. I just arrange my windows, the notepad window and the bash shell in such a way that I'm able to see the path. So here, first of all, I say cd backslash. I should be at the root. Then I say cd users. Okay, let me check where I am. cd backslash didn't work. Okay, so looks like I'm already into user Saket. Because all these folders are under Saket. Okay. So here I say then cd OneDrive slash. This is bash shell, so you have to use forward slash instead of back. Then I say desktop /. I type QU and press tab. It just completes it to Quinnox / I type TE and press tab. So it completes to demos / web. I type and press tab. So it completes to web APIs. And then I say APIs or API underscore demo web API with EF and press enter. So I'm into that path. Okay. Here I want to initialize the local Git repository, for which I just issue the command git init. Now by initializing the Git integration has initialized, but my project is not yet added to it. And that's why it gives the prompt that initialize empty Git repository in this path. So there is a folder .git it has created here, which contains all the configuration for Git for this project or for this folder. To add the current folder to this repository, I have to say git add dot okay, and my current project will be automatically added. I mean, the files in the current folder and the subfolders and their subfolders, everything will get added. If you are looking for a specific file or specific directory to be added, you can specify the exact name of that file or that directory instead of dot after add. Is it clear?
Yes.
Now, this is just added to the Git cache, I would say. It's not actually added to the repository. Until and unless I don't say git commit, it won't commit anything. And here I need to actually give some comment also or a name also to the commit. So because this is the first time commit, I'll probably name this as initial commit. So whenever the project is started, the project structure is created. This is what you do. Understand? And later on, everyone clones the repository and just keeps on making the changes and again committing the changes. And to keep your main branch safe, probably then you can go for creating the branches and making changes into them, making commit into them, then create the PR. And then once the PR is accepted or approved, probably then you can go for merge. So slowly we'll be learning all of these. So put that git commit -m space within double quotes initial commit as the comment or name for the commit and press enter. Clear?
So it will be in our local system only, or
Local. As of now, it's local.
okay.
Is it clear?
Yes.
Okay, so remote repository we'll be learning in the next session how to create the remote repository and how to push the local repository to the remote repository. Right, so that will require some account to be created on the remote repository service. It could be GitHub, it could be GitLab, Bitbucket, or Azure DevOps, wherever I can create my account for free, probably I can go for that and I can use the uh, same repository there onwards. So we'll be using GitHub precisely. So I would request all of you to create a GitHub account on github.com before we start with the next session. Okay.
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 Okay. So that is it for today. And in the next session, we are going to be heavily loaded. Lot of stuff we will be doing. And it will be more of hands-on thing only, like creating the remote repository, configuring it, then pushing the local repository to the remote repository, and then branching and various uh, commands that the Git offers, the creation of the pull request, right? Doing the review and then merging. So these are the things that we will be looking at in the next session. Clear?
Yeah.
Yes.
Saket, I have one doubt. So today
Yes.
we have created this Git init and we pushed our code to Git, right?
Yes. Yes.
So
So local
it
Git.
is. So it will be in connection with the upcoming session or
Yes, it will be.
okay.
Okay. The same repository will be pushing to remote. Understood?
So what we created in local, it will be pushed to.
Correct. Correct. So that it can be shared across the world. Yes.
Okay. Yes.
Okay, then. See you on
Saket,
Friday. Yeah,
I'll send you that repository of project
sure.
on your email.
Sure. So those who are already aware of can do it right away. Those who don't know, just wait for the next session where we'll be learning it how to do it. And then you can share it on Friday also. No problem. Meanwhile, if you want any improvisation to be made in that assignment, you are allowed to do that. Okay?
Okay.
Thank you.
Yeah.
Thank you.
So thanks, and let's meet on Friday, 9:30 a.m.
Yeah, sure.
Thank you, team.
Sure.
Thanks.
Thanks.
Bye.
Bye-bye.
You.